remote sensing and GIS and GPS. So this is the from second year and fourth semester. So this course is Skill Enhancement Elective Course 1. Just 1 second. So now we are going to introduction to remote sensing. Okay. So now what is remote sensing? Now the term this remote sensing is often wrongly applied to satellite borne imaging surface only. So the remote sensing is the common name. Okay. Common name for all methods used to So all the methods used to collect data at a distance from the object, right? Object under study by some kind of recording device, right? So the use of remote sensing techniques is increasing rapidly. So the finding new fields of application as technology advances in developing the remote sensing systems. So the main with this objective is the remote sensing is not a full review existing remote sensing methods, but rather to introduce the concept of remote sensing, right? So a brief history of remote sensing is according to the definition that a pair of binoculars or an ordinary camera. So those are simple remote sensing systems, right? So the camera that is, it was used already during the end of the 19th century, right? So that is, for example, in military reconnaissance. So that is having the obvious advantage over simple visual inspection in the fact that it produced an image that could be studied and reproduced in several copies. Since the late 1920s, the aerial photography has been an important tool in all kinds of mapping and also planning work, right? So during World War, right, World War II, the two new remote sensing methods were developed in that time. Which time? The World War II, right? So the sonar and the radar, that is sonar, SONAR, sonar and radar, right? RADAR, right? RADAR, sonar and radar. So these are the new remote sensing methods. So they are developed in that time, that is in World War II, right? So after World War II, the several systems have been developed for different types of electromagnetic radiation. So the remote sensing systems based on electronic radiation detectors, those are not obviously image generating systems. So that is the result is not an image, but rather a set of number of stored in a computer compatible format, right? So the stored data can often be transformed into an which one? Image. Image by which one? Computer, using computer dedicated software, right? So the remote sensing data are an example of primary data, which are used for environmental and climate related studies also. So this remote sensing works on the basis of which one? Electromagnetic radiation. This is the very important. Remember EMR. It's called EMR, electromagnetic radiation. So the EMR interact with the which one? Atmosphere, and which one? Surface of the earth features. Surface of the earth features. So the interaction determines spectral characteristics of Earth surface features, and based on that, these features can be identified, right? So there are various types of remote sensing systems which are used for specific application areas. So now in your topic, you can learn all the basic concepts of remote sensing, interaction of electromagnetic radiation with atmosphere, and also earth surface features and spectral characteristics of common surface features. So what are the common surface features? Those are vegetation, right? Vegetation, vegetation, and also soil, and also water, etc. Right? So now the remote sensing definition is when we observe an object through our eyes. Okay, our eyes. Okay. So when we observe an object through our eyes, we are actually engaged in remote sensing, right? And our eyes act as remote sensors. So the remote sensing is the process of which one? Acquiring information, that is sensing from a which place? Distance. From a distance. It means remotely. So the remote means without coming into physical contact, right? Without coming into physical contact with the futures. And sensing means that is acquisition of information, right? So sensing is of the earth surface features through some instrument placed on aerial or satellite platforms. Okay. So there are several formal definitions of remote sensing. According to the American, right? American Society for Photogrammetry and Remote Sensing, RS. It's called ASPRS, right? American Society for Photogrammetry and Remote Sensing. So the remote sensing is the measurement or acquisition of information of some property of an object or phenomenon by a recording device that is not in physical or intimate contact with the object or phenomenon under study. So that is Colwell 1983 study, right? So, and also some of the definition is there that is Campbell 2002. He has defined remote sensing as the practice of deriving information about the Earth's land and water surfaces using image acquired from an overhead perspective using electromagnetic radiation in one or more regions of the electromagnetic spectrum reflected or emitted from the Earth's surface. And according to the Lillesand and Kiefer in the year of 1979, they are told remote sensing is the science and art of obtaining useful information about an object, so area or phenomenon through the analysis of data acquired by a device. So that is not in contact with the object, area or phenomenon under investigation. So these definitions refer to remote sensing as both an art and also science, right? So not only science, those are refers to arts and science. So the remote sensing is a science when information is extracted from remote sensing data using some scientific facts, whereas it is an art when information is derived through background or prior knowledge obtained through experience. So remote sensing and our analysts derived information from remote sensing data using both scientific facts and also their experience. So sorry, after this introduction, now we are going to uh, remote sensing process, right? So now, what is the remote sensing process? The process of remote sensing involves several steps, right? You see, you can observe in this figure. So we know that our eyes are an example, right? I already told in this slide. Our eyes are an example of remote sensors. That is the exact example. So we observe objects because there is a source of radiation that interacts with the objects, and the radiated light is captured by our eyes. Eyes means that is sensor. So eyes send signals means that is data, right? That signals to our brain. That is called processor, right? So the processor, you see here, now the radiated light, right? You see here, the radiated light is captured, which one? By our eyes. Those are called sensors. And eyes send signals. That is called data. Signals from where? So signals to our brain. Okay. So that is called processor. So that process the data and convert it into information. So these remote sensing processes you see, this is the picture. Now you see, I gave letters A. So A is energy source and B. Where is B? This one. So B is um, energy interaction with the atmosphere, and C is what is that? C is interaction of electromagnetic radiation with Earth surface features, and D is recording of energy by sensor. And E is transmission of remotely sensed data. Their reception by ground station and their processing. And F, where is F? Here, right? So F is interpretation and analysis of the data. So the information derived from remote sensing data is generally presented in the form of a map or table, right? So now you see one by one, A. This is the A, okay? So A is what? Sources of energy, sources of energy. So the source of energy, so that is the first and very important requirement for remote sensing. is an energy source which provides electromagnetic, right? Electromagnetic energy to the which one? Earth. Okay. So it may be either from natural or artificial. Natural means solar radiation, right? And artificial means radar sources. So for remote sensing, sun's radiations are commonly used as a source of energy, right? So that is the A, that is the source of energy. And B, you see here B. So B means interaction of energy with the atmosphere. Okay. So when energy travels from its source to the earth surface, okay? So it comes in contact with the earth's atmosphere where it interacts with atmospheric constituents. So the energy reflected from earth's surface is received by remote sensors. So in this process, the energy once again interact with which one? Atmosphere. Okay? Atmosphere. So now C. Where is C? This one here. Okay? C means the interaction of energy with earth surface features. Okay? So the energy reaching the Earth's surface through which one? Through the atmosphere interacts with the Earth surface features. So the interaction and its outcome depend on the characteristics of the features and the energy. And now we are going to D. Where is he? D here. Okay. So D means recording of the energy by sensors, right? So after interacting with the earth surface features, the reflected and emitted energy travels to the sensor, and the sensor records the reflected and emitted energy, right? Next, we are going to E. E means that is transmission, reception, and processing of the recorded signals. Okay, so this one E. Okay, so that energy recorded by the sensor is transmitted in the form of signals to earth stations. This one. Okay. So that receives and process the signals. So the electronic signals are processed and converted into an which one? Image. Okay. Image. Now we are going to next one is which one? F. Okay. So F is interpretation and analysis of the data. This one. Okay. So interpretation, that means the processed image is interpreted, right? So and analyzed to extract information about the object of interest. That is our systems or softwares, etc. Right? So these are the remote sensing process step by step, right? You see, first one is source of energy and second one is interaction of energy with the atmosphere. Third one is interaction of energy with earth surface feature. And fourth one is recording of the energy sensors. And next one is transmission, reception, and processing of recorded signals. And last one is interpretation and analysis of the data. So this is the remote sensing process. Now we have some of the advantages and limitations is there. that is at surface features from horizontal perspective, whereas remote sensing provides us a bird's eye view of the earth surface, right? Bird's eye. So this overhead perspective gives us a very different view of the earth surface features. So now, what are the advantages? Those are it provides a synoptic view and it can acquire data of inaccessible areas, and also it is a cost-effective means of data collection, and it can provide data in wavelengths beyond the visible range of human eye. And also it is an unobstructive means of data collection which does not change characteristics of the object or phenomenon it being observed. And also it provides historical data sets that are useful to understand characteristics of an object in a given point of time in the past. Right? Now we are going to electromagnetic radiation. So now what is the electromagnetic radiation? Electromagnetic radiation. So now it's called, I always told EMR, right? So the electromagnetic radiation refers to waves of the electromagnetic field propagating through space. It includes radio waves, microwaves, infrared and visible light, and also ultraviolet, X-rays, and also gamma rays, right? So the electromagnetic radiation consists of oscillating electric and magnetic fields perpendicular to each other and the direction of propagation. So the characteristics of the EMR depend on its frequency or wavelength, which determines its energy and properties. Right? So now we can see something, right? Something only in the presence of light. It meaning when the object is illuminated, right? Object is illuminated with a source of energy, right? This source of energy, this one, okay? A source of energy. So the sense associated with eyes is known as sight or vision, and it is stimulated by light. So the eyes convert the incoming light, right? Incoming light into electric signals. Electric signals and convey them to brain. Okay? Convey them to brain. So which creates pictures or image in our mind after this processing. So similarly, as you have seen in this figure, right? So that remote sensing device records energy that has interacted with the Earth surface features, right? So this energy serves as the main communication link device between device and futures. Okay, between device and objects, device and objects. So for remote sensing, the first requirement is a source of energy. This, right, source of energy, and the natural source of energy is the electromagnetic energy emanated from the this sun. Okay, so in some of the physics books on that school level, that energy is transferred in three waves, right? What is that? Three waves. First one is conduction, COND. And second one is convection, And third one is radiation, right? Conduction and convection and radiation. So unlike the conduction and convection, radiation does not require a medium to transfer energy through. So radiant energy is defined as the energy carried by electromagnetic radiation. You know, that everything that has a temperature above absolute zero radiates energy, right? So in the context of remote sensing, our interest is in the transfer of energy, right? Transfer of energy by radiation, because it can take place in a vacuum and in the atmosphere in the region between the sun and the earth, right? So now the models of this electromagnetic radiation, it was conceptualized by Maxwell. You see, okay, Maxwell in the year of 1862 as electromagnetic wave consisting of electric and magnetic fields and traveling through which one space at the speed of light. So the two fields are at high angle to each other and are perpendicular to the direction of propagation. Both the fields have same amplitude, which reach their maxima and minima at the same time. So the two important characteristics of this electromagnetic radiation are the wavelength and frequency, so which are significant for understanding the remote sensing, right? That now the particle model was given by which one? Sir, Sir Isaac, IES, Isaac, sorry, Sir Isaac Newton, right? Newton is famous person, all of you know about this. So in the year of 1704. So the particle model explains that it behaves as if it consists of many individual bodies called, what is that? Photons. Photons. Or it's called quanta. 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 So according to this, the light behaves as a stream of particles and travels in straight line. Okay. The both the aspects, that is a wave or particle, it make up light at the same time. So this leads us to the current ways of describing light. The model known as wave particle duality. It's called wave particle duality. So, wave particle duality postulates that all matters exhibit both wave and particle properties. So, now different photons can possess certain quantities, right? Certain quantities of the energy. The photons with specific energy levels occupy specific positions in this electromagnetic radiation or electromagnetic spectrum. Okay. Now you see what is the electromagnetic spectrum. Electromagnetic radiation extend electromagnetic radiation extends over a wide range of wavelengths, right? Wide range of wavelengths. So the entire range of radiant energies is called electromagnetic spectrum. That is EMS. EMR means electromagnetic radiation. EMS means electromagnetic spectrum. So the EMR, electromagnetic radiation, ranges from very high, right? Very high energy radiation, such as um, gamma, right? Gamma rays and X-rays through ultraviolet light, okay, and visible light and infrared radiation and also microwaves to radio waves as radio waves like, right? You see here this one. So these divisions, right? These divisions are ordered according to their frequency, wavelength, or wave number, right? So our eyes are sensitive to only a small portion of the electromagnetic spectrum that is called visible range. So the radiations beyond the visible region are invisible to our eyes, but it can be detected by some remote sensing devices such as the thermal sensors. So that can sense the radiations in the thermal infrared region. So you should note that that the division of the electromagnetic spectrum that is for practical purpose only. The gamma rays and X-rays, right? Gamma rays and X-rays are potentially those are very dangerous, right? And also the ultraviolet light is powerful enough to cause sunburn, right? Cause sunburn. So you can feel infrared radiation as heat, right? So you know that we employ microwaves in microwave ovens and radio waves are used for communications. Nowadays we are using headphones, earbuds like that, right? So all the type of electromagnetic radiations are waveforms which travel at the speed of light. So the radiation can be defined in terms of either their wavelength or frequency. The shorter wavelength radiations, shorter wave means infrared or shorter waves, right? So those are generally described in terms of its wavelength, whereas longer wavelength radiations, so those are generally described in terms of its frequency, right? And now you can observe these divisions, right? So the electromagnetic spectrum is divided in different regions based on which one? Wavelength for practical purpose. So although the electromagnetic spectrum ranges from gamma rays to radio waves, remote sensing is generally restricted to the range from ultraviolet to microwave regions. That is, you see, you can observe in this table, you see here, these are the divisions and subdivisions and wavelengths, right? So in ultraviolet division, that is 0.01 to 0.38 micron. Oh, that is wavelength means 0.01 to 0.38, right? And also visible. Visible 0.4 to 0.7. So in that, you see, you can observe here blue, green, red, right? So that is called RGB, right? RGB, blue, green, red. Blue means how much? 0.4 to zero point 0.5, 0.5, and green means 0.5 to 0.6, and red means 0.6 to 0.7. Now you see here, sorry. Infrared. In infrared, near infrared. You see here near infrared, the middle infrared. So near infrared means 0.7 to 1.3, and middle infrared, that is 1.3 to 3. Far or thermal infrared. Far or thermal infrared means 3 to 30. Right? Now we are going to microwave. So that is 0.1 to 100 centimeters. This one centimeters. And you see here, Who So that is called X. X means 2.5 to 4. And C is 4.4 to 8 centimeters. And S is 8 to 15 centimeters. And L is 15 to 13 centimeters. So these are some of the electromagnetic spectrum divisions and subdivisions, right? Now, electromagnetic radiation interactions with the atmosphere and the earth surface. Sorry, this is EMR in interaction with the atmosphere. It is combining earth surface, right? So we know that electromagnetic radiation is the basis of remote sensing. And most of the remote sensing sensors use from which place? Sun's energy or sun's radiation for collecting information about objects on the earth surface. So the sensors record the radiation. The sensors record the radiation coming from the sun after interacting with the atmosphere and the earth surface. The particles and gases in the atmosphere, it can affect the incoming light or radiation. So the radiation reaching the remote sensor is modified significantly because of the process taking place in the atmosphere and the earth or surface of the earth. So in this, now we are going to EMR atmosphere, electromagnetic radiation or atmosphere. interaction. So that this, you see, you can observe in this figure, the electromagnetic radiation after generation travels through the vacuum and then through the Earth's atmosphere. The atmospheric constituents interact with the electromagnetic radiation and affect the wavelength, intensity, and spectral distribution caused by absorption, scattering and refraction and reflection mechanisms, right? So the interaction of electromagnetic radiation with the atmosphere is very important to remote sensing for two main reasons. So those are, first one is information, information, right? Information, 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 information carried by which one? Electromagnetic radiation reflected or emitted by the Earth surface. Earth surface is modified while traversing through the atmosphere. And next one is interaction of electromagnetic radiation with here it is interact with earth surface, but here with the atmosphere, right? Atmosphere, it can be used to obtain useful information about the atmosphere itself, right? So now we are going to absorption. First one is absorption. What is absorption? In this process, the absorption radiant energy is converted into other forms of energy and emitted at different wavelengths. So pure gases. What are the pure gases? Those are nitrogen, oxygen, argon, and carbon dioxide, and also water vapor and ozone. So these are the pure gases. So and the particulates. Particulate matters means particles of various sizes originated from dust, smoke, etc. So that is PM 2.5 or PM 10, etc. Right? So those are absorbed energy at different wavelengths and at different attitude. Example, near complete absorption of radiation at wavelength shorter than uh, zero point 0.3 micrometers by ozone. So that is the reason behind the protection of Earth from ultraviolet radiation. So the largest amount of solar radiation is absorbed by water vapor at around how much? 6 micrometers, right? 6 micrometers. So the portion of the electromagnetic spectrum for which atmosphere is transparent are known as atmospheric window, right? Hmm. Atmospheric window, right? It's called atmospheric window. So the remote sensors are designed in such a way that they operate in these atmospheric windows because energy outside the atmospheric windows is severely attenuated by the atmosphere, right? Atmosphere, and hence it cannot be effective for remote sensing. The commonly utilized atmospheric windows are the visible window. Visible window means 0. You see here, visible here 0.4 to 0.7 or 5, right? Okay. And the microwave window means 2 to 4 millimeters, right? So, however, the meteorological satellites directly measured absorption phenomena. Next one is scattering. This is the scattering, second one. Say this one, say scattering. Scattering means the radiation illuminating the earth has both direct sunlight and diffuse skylight, right? The scattering in atmosphere is the diffusion of radiation by atmospheric particles. It causing redirection of the electromagnetic radiation from its path. So the scattering depends upon the wavelength of radiation and size of particles and traveling distance of the radiation through the atmosphere, and hence those are classified as selective and also non-selective scatterings, right? Selective and non-selective. So selective scattering means that is wavelength dependent, whereas non-selective scattering is wavelength independent. Okay. So the selective scattering of selective scattering is that is two types of that is Rayleigh and Mie scattering. Ray, R-A-Y, L-E-I-G-H, Rayleigh, and Mie, M-I-E, Mie scattering. So that are more relevant to remote sensing, right? So these are more relevant. So relay scattering is caused due to gas molecules. Gas molecule means already I told that oxygen, nitrogen, carbon dioxide, particulate matters and also ozone, right? So those are having effective diameter much smaller than the wavelength of incident radiation. So this type of scattering is inversely proportional to the fourth power of wavelength of radiation. So this scattering is responsible for sky's bluish appearance, right? Sky's bluish appearance. It's look like a sky. Sky means bluish, blue color, right? So in the lower, the 4.5 kilometers of the atmosphere, there are essentially spherical particles that is having diameter nearly equal to the wavelength of incident radiation causing. And my scattering, right? My radiation causing, that is called my scattering, right? So the main scattering agents for visible spectrum are water vapor, and dust, etc. So those are having diameters from few tenths of micrometer to several millimeters, right? In the lowest part of the atmosphere, there are the particles having diameters much larger, greater than 10 times than the wavelength of incident radiation. So this scattering is not dependent on wavelength of radiation. Hence, that is called non-selective scattering, right? Non-selective scattering. So this causes the sky to appear with this during heavy haze condition because of nearly equal scattering of blue, green, and red light, right? RGB. So the scattering causes reduction of contrast in images due to reduction of brightness difference between the sunlight and shaded areas of the ground. So the reduction in contrast lowers differentiation between objects in an image. So the radiation that has been scattered in the Earth's atmosphere and it has reached the sensor without contacting the Earth's surface, that is called path radiance, right? Path radiance, PATH, path radiance. So that is essential to remove the path radiance from remote sensing images before any image analysis, particularly while analyzing temporal images or pictures. And next one is refraction, right? This one. Refraction means when light enters from one medium to another medium of varying density, then refraction occurs, right? So the atmospheric refraction takes place due to variation in air density, so which varies with altitude. So it causes astronomical objects to appear higher in the sky than they are in reality, right? So it affects the complete spectrum of electromagnetic radiation in varying degrees. For example, suppose in visible, right? Visible light, that is blue is more affected than red light, right? So the amount of atmospheric refraction is a function of temperature, pressure, and humidity. So this is the cause of twinkling of the stars and deformation of the shape of the sun at sunset and sunrise. Okay. So that's the main reason. So the atmospheric refraction is minimum in the zenith and maximum at the horizon. So this may cause some errors in images. However, these errors can be predicted, right? Predicted by Snell's law, Snells, Snell's law, and hence it can be removed, right? Now, last one is refraction, right? Refraction. It means it is the fundamental, right? Fundamental characteristics important in remote sensing. So in this reflection process, the radiation bounces off. Radiation bounces off. It means an object such as the top of a cloud and other materials in atmosphere. Right? So the blur image, right? Blurred image and presence of cloud in remote sensing pictures or images, those are the main problems associated with the reflection in the atmosphere. The change in incident radiation on its way towards Earth's surface and back to satellite sensor is governed by several atmospheric effects, right? Several atmospheric effects. Now we are going to, so now up to here, the in EMR interaction with the atmosphere is over. Now we are going to Earth, right? Earth surface, interaction with Earth surface, right? So now we have read about several phenomenon in the previous subsection, right? Or the radiation which is neither absorbed nor reflected in atmosphere reach that is surface of the earth. When the radiation is incident upon the earth's surface, absorption, transmission and reflection, it may take place. So however, the degree of these process will depend upon the wavelength of the energy and the type and condition of the object. So the electromagnetic radiation incidence upon Earth's surface is either transmitted into the surface or scattered, reflected, absorbed and emitted by the surface. So the remote sensing devices detect these changes, right? The changes, hence analysis of the image provides information about the object of interest, right? So there are reflection of the electromagnetic radiation from the each sorry, from the each earth surface feature, right? So that is understanding the of reflection is important since about the third of the energy from the sun is reflected. So the spectral reflectance, spectral means that is the ratio of reflected energy to incident energy as a function of wavelength. That is depends on wavelength. So it has different values at different wavelengths for a given terrain feature. So various materials of the Earth's surface have different spectral reflectance characteristics. So the spectral reflectance is responsible for the color or tone in the photographic image of an object. So trees, now trees are appears green, right? So because they reflect more of the green wavelength in comparison to others, right? So when electromagnetic radiation travels to the Earth's surface through atmosphere, it parts of the energy gets scattered from the surface and a part of the energy gets transmitted through it. So when the material is homogeneous, the radiation is transmitted, but in homogeneous media, the transmitted radiation gets further scattered. The signal received by sensors, that is combination of now both the scattering process, that is surface and volume scattering respectively, right? So there are three major regions in electromagnetic radiation earth interaction that are important in remote sensing. So the visible and NIR spectral band from 0.3 micrometers to 3 micrometers. So that is known as reflective region, right? Reflective region. So in this band, the sun's radiation sensed by the sensor is reflected by the Earth's surface. So the band corresponding to the atmospheric window between these 8 micrometers and 14 micrometers is known as thermal infrared. The first one is reflective region. So this is the band corresponding to the atmospheric window between 8 to 14 micrometers is known as thermal infrared. Okay, thermal infrared. So the thermal infrared band. So the energy available in this band for remote sensing is due to the emission from the Earth's surface. So both the reflection and self emissions, those are important in the intermediate band from 3 micrometers to 5.5 micrometers. Okay. So this is the introduction of the remote sensing, etc., and electromagnetic spectrum also, right? So now today's class is over. So we'll continue the next class and tomorrow.